So let's get into this. We are still solving the Indical equations, but this time around we have it for a pair of equations. In mathematics, when we have a pair of equations that we want to solve together, we have it to be called simultaneous equation. So simultaneous means occurring at the same time. Okay, and depending on the number of unknowns you will have a number of equations to match that as well. So in this case, we have only two unknowns, so x and y. So we have two equations to match that as well. So two equations, two unknowns, three unknowns, three equations. That's how it works. If you have only one equation, you have one unknown to solve. So a good prerequisite for this video is that you learn how to watch you know how to solve simultaneous equations. So if you don't know how to solve simultaneous equations, you can check out the video of it on this channel. But if you do, you are free to carry on. So let's solve these questions together. Let's solve the first one. So let's solve it on the first page. It says 2 to the power of 2x plus y equals 32, and 2 to the power of 2 open bracket x minus y equals to 4. So just like the examples we've been solving, all we just need to do from here is that we break things on the left hand side and the right hand side down. That is, we express them in the same power, in the same base. So in this case, we can express things here in power of 2 and here in power of 2. So in the first case, we have 2 to the power of 2x plus y equals to 32. We can represent 32 to be 2 to the power of 5. So 2 to the power of 2x plus y equals to 2 to the power of 5. So now, because we have the same base for both ones, for the left hand side and the right hand side, we can write this to be 2x plus y equals to 5. So what we just did is we equated the powers. So because their bases are the same. So if their bases are not the same, we don't equate the powers. So we have 2x plus y equals 5, and that is the equation 1. Okay, so then the next thing is to work with this. So the next one is we have 2 raised to the power of 2 open bracket x minus y equals to 4. We can break this 4 to be 2 to the power of 2 open bracket x minus y equals to 4 is 2 to the power of 2. So the same thing as well, 2 and 2. So we can equate the powers and say this is 2 open bracket x minus y equals to 2. Right? So we can open the brackets here, or we can divide both sides by 2. So we have that to be x minus y equals to 1, and that's the equation 2. So the pair of equations we have are 2x plus y equals 5 and x minus y equals 1. So let's write the equation 1 and equation 2. So a good idea is to solve them using the elimination method. And to solve using the elimination method, all we need to do is add. So 2x plus x is 3x, y plus minus 1, plus times minus is minus, y minus 1 means it is eliminated. And then we have 5 plus 1 equals 6. If you divide both sides by 3, we have that x is equals to 2. So we've solved for x. Let us substitute x equals to in equation 2. So we say something around the lines of substitute x equals to in equation 2. So equation 2 says x minus y equals 1. So we have that x minus y equals to 1. So if x is 2, we have 2 minus y equals 1. And we have 2 minus y. We collect like terms. 2 minus 1, take 1 to the other side, is equals to y. we can flip it and say y is equals to 2 minus 1, which is 1. So that means at the end of the day, we have that x is equals to 2 and y is equals to 1 to be the solution of the first Indical equation that we are solving. So that's a neat question. Now we had y is equals to 1 and x is equal to 2. So as easy as that. So that's the answer to the first one. So let's move on to the second question, which is here. So it says 3 to the power of x minus 2 to the power of y plus 2 is equals to 49. And 2 to the power of y minus 3 to the power of x minus 2 equals to minus 1. This is another pair of simultaneous equation in the Indical equations world. So let's solve them together. So we have it from here. So let's put it here. So we see we have 3 to the power of x minus 2 to the power of y plus 2 equals 49, I suppose. Okay, so we have 2 to the power of y minus 3 to the power of x minus 2 equals minus 1. So that's what we have there as well. So what we do is that we try to break things down, okay, just like we learned in this first example. So we learn to break things down. So how do we break things down here? We can say that, oh, we have a problem first of all. Now we have 2 to the power of y plus 2. We have that situation going on. And what does this mean in this indices now? So if you look here, we have something like 2 to the power of, let me show you, 2 to the power of y plus 2. It's like saying 2 to the power of y times 2 to the power of 2, basically, because if we move from here, we can add the powers. So if you have it like this, we can do the reverse case of it, which is saying 2 to the power of y times 2 to the power of 2. So we can go from left to right and from right to left, depending on the use case. So for this question, it is much easier for us to express it and split the powers like this. So that is what we are going to take you through. So similarly, where it says 3 to the power of x minus 2 is coming from the indices law that says 3 to the power of x divided by 3 to the power of 2. So that's what we are going to do. Okay, so in the first case, let's start our simplification journey from something like that. We have 3 to the power of x minus 2 to the power of y multiplied by, so I'm using this dot to show that there's a multiplication thing going on. So that dot there says multiplication, and it means 2 to the power of 2 equals to 49. So going on, we are having 3 to the power of x minus 2 to the power of 2 is 4. So it's like saying 4 multiplied by 2 to the power of y is equals to 49. So let's hold up to it. And let's do the other one now. So for the other one, we had 2 to the power of y minus 3 to the power of x minus 2 equals to 1. So you know we can write it as 2 to the power of y minus now 3 to the power of x over, because now this divide, you can write it as over. So we have it to be over 9 is equals to 1. So now let's see how we can continue from there. So recall that for this first case, we had 3 to the power of x minus 4, open bracket, 2 to the power of y equals to 9. Okay, so we are going to apply a little bit of a trick. And the trick is this, is coming to the sense that we can kind of see some kind of pattern going on in our question. This is the first one here, and this is what we had for the other one. This is what we had here, and this is what we have for the other one, which is 2 to the power of y minus 3 to the power of x over 9 is equals to 1. This is what we have after breaking them down to their normal form. We can represent that, we can see that 3 to the power of x is in both of them, and 2 to the power of y is in both. So it could do us a little bit of good if we represent 2 to the power of y by another letter, just as a little bit of a placeholder, because it makes us see things happen better. we could say that, oh, let's say A is equals to 3 to the power of x and B is equals to 2 to the power of y. So once we do that, let us re-represent our equation and say something like, okay, we have A minus, now A is 3 to the power of x, so A minus, now 4, now 2 to the power of y is B, so we have 4B is equals to 49. Okay, so I meant to say 49 here, so this is 49, and that becomes our equation 1 that we have for our simultaneous equation. So on the other one, remember 2 to the power of y is B, so you can say for B minus 3 to the power of x is what? A over 9 is equals to 1. So let's try to get rid of this fraction that we have here, and we can get rid of fractions by multiplying through by the LCM of denominators. The only denominator we see here is 9, so we can multiply each term by 9. Say 9 times B minus A over 9 times 9 equals to 1 times 9. So that will give us 9B minus 9 cancel 9. We are left with A is equals to 1 times 9 is 9, and which we can rearrange to be say minus A plus 9B equals to 9, and that is the equation 2. So you can take equation 1 and equation 2 and solve simultaneously now, and write it as A minus 4B, and say A minus 4B equals to 49. We have minus A plus 9B equals to 9. So plus 9B equals to 9. So we have that equation 1, and this is equation 2. So what do we do from here? I think a good option is to try and eliminate A. Since A is plus here and minus here, so we have different signs, we can add to eliminate. Once we have different signs in our simultaneous equation, like A and minus A here, as far as they have the same coefficients anyway, or like in the first example where we had like plus y and minus y, you can see both of them have a coefficient of 1 here and minus 1 there, so we can add it there. We can add the equation. So we have A minus, if we add the two equations, we can say A plus minus A. Plus times minus is minus, so A minus A is 0. Now we have minus 4B plus 9B. That's A minus 4B plus 9B, which will give me what? 5B, which is equals to 49 plus 9. 49 plus 9 is 58. Okay, so it says 58. That looks a little bit weird. So let's check things around from where we have it. I think there might have been a mistake. It's not wrong to have that kind of answer. I'm just more or less suspecting that I might have made a little mistake. Let me check. Okay, so the second equation here says minus 1. So, oh, look here. It looks like I wrote just 1 here. So this is supposed to say minus 1 while I was taking it from here to analyze, to break down. And this is what? Minus 1. So that means this makes it minus 1 here. And when we multiply through, it's minus 1 here. Okay, so this is the first one, and this is the second one as well. Okay, so this is minus 9, and this is minus 9. Okay, so that's the mistake. So when we take it from here to solve simultaneously, it should be minus. So 49 plus minus 9 is 49 minus 9, which should give us 40. Okay, now that seems to be better because we're having numbers like that, whole numbers. So we divide by 5 now. Okay, we have B equals to 40 divided by 5 gives us 8. Okay, so we've gotten B as 8. So the next thing for us to do is to substitute so that we can get A. You can say substitute B equals 8 in any of the equations. Let's pick equation 1 in equation 1. Equation 1 says A minus 4B equals to 49. So A minus 4, open bracket B, which is what? 8, is 49. So a minus 32 equals 49. Take it to that side, we have a equals 49 plus 32, and 49 plus 32 is equals to 81. So a is 81. So at the end of the day, we have a equals 81 and b equals 8. Now, we are not done with the original simultaneous equation that we have to solve. So the original equation we have to solve says that we should find x and y. While trying to solve it, we broke things down and we came up with this neat idea that, okay, let a equals 3 to the power of x and let b equals 2 to the power of y. Now we have gotten the a and b. We need to recall these two things that we said here. So we could say that, oh, recall that a is this and b is this, so that we can get our x and y from there. We can say that recall a is equals to 3 to the power of x. A is equals to 3 to the power of x and y, and b is equals to 2 to the power of y. So when we handle that, we can say that, oh, a, which is 81, is equals to 3 to the power of x. We can break 81 down to be 3 to the power of 4. And 3 to the power of 4 is same as 3 to the power of x, which means that x is equals to 4 when you equate the powers. So equating the powers means that x is equals to 4 because the bases are the same. As far as the bases are the same, we can equate the powers. So then again, your b is equals to 2 to the power of y. So 8 is 2 to the power of y. So 8 is equals to 2 to the power of y. Can represent 8 as 2 to the power of 3 equals to 2 to the power of y. So since the bases are the same, we can say that y is equals to 3. So your answer at the end of the day is that x is equals to 4 and y is equals to 3. That is the solution of the simultaneous equation that we've been solving, these two pair of equations. So from this video, we've solved these two equations. So the first one and the second one, both have been solved here. So in the first case, that one is much easier. It's quite straightforward as well. But in this second case, we have to do some manipulation here, some simplification here, before we arrive at our simultaneous equation, and then we solved. So that is how the idea of indical equations work.